Hello, this is Systems of Linear Equations and Inequalities, graphing and solving systems of linear inequalities, example 1, and this is the system that we're going to graph, and we've already graphed these individually where you've only had to graph one of these. This is very similar. We're just going to graph two of them on the same set of axes, and the solution will be where these overlap. So the graph of this one is a half plane and the boundary is a line. This one's a half plane, and like I said, we did some of these, and that was in chapter 2 section 6 example 3 is a good example. So anyway, these are the boundary lines. See, it's y equals negative 3x minus 1, and because that's or equal to, that would be a solid line because this line is part of the solution. Now here, this has to be strictly less than, so this equation, this line, is not part of the solution, so it's a broken line. So the first step is going to be to graph these two, and both of the equations are already in slope-intercept form. So to graph them, we'll graph the intercept and we'll use the slope. So the intercept for this first one, the y-intercept for the first one, is negative 1. So that's 1 point on the line, and I got that from here. And now the negative 3 coefficient of the x means that the slope is negative 3. So I can go down 3 and to the right 1, or I can go up 3 and to the left 1. So let's see, down 3 and to the right 1, down 3 and to the right 1, or we said we can go up 3 and to the left 1, up 3 and to the left 1, up 3 and to the left 1, and we have this line, and I'll draw it as solid. So we need to figure out if the solution is to the right of the line or to the left of the line. So one thing to do is you pick a point that's not on the line, and a handy point is always 0, 0, because 0, 0 is easy to substitute in. When I substitute 0, 0 into this equation, I get 0 is greater than or equal to negative 1. And that's true. 0 is greater than or equal to negative 1, so that means the solution is everything on this side of this line. And I'm just going to shade very lightly, not too dark, because our solution has to also include this. And let's get this line graphed, and I'll do it the same way. We'll use an intercept of positive 2, and the slope is 1. So if the slope is 1, I can use 1 on top of 1 or negative 1 on top of negative 1. And in this case, I think 2 on top of 2 or negative 2 on top of negative 2 for 1 would be a good choice. So I can go down 2 and to the left 2, down 2 and to the left 2, or I can go up 2 and to the right 2. If I use this as the slope, up 2 and to the right 2, up 2 and to the right 2, up 2 and to the right 2. So now this line is a broken line because it is not part of the solution. Okay, now I know it's kind of tricky, but you need to put the dark line and the shaded area outside of your mind. Just imagine that we didn't have that there, and we're figuring out if the solution for the second inequality is this way or this way. And 0, 0 is a good point. Here I would have 0 is less than 2. See, if I put in a 0 for y, a 0 for x, that's the point 0, 0. And that is true. 0 is less than 2. So everything to this side of the line is the solution. Now, I'm looking for the places where the solutions intersect. See, now in this area out here, both of the solutions do not intersect. This is only shaded from this one. Now in here, this is all shaded by both. See, we shaded already when we were graphing the solid black line. Okay, so this that I'm shading right now is for both, and I'm shading it a little bit heavier so that we can see what is the solution here. And this part up here, this was just shaded once. This was shaded for this line. This was shaded just for this line. And this part that I'm shading heavily is for both lines. So if we graph the system, this is how it looks. Maybe some light shading here, some light shading here, but this dark shaded area is the solution. This black line is part of the solution. The dotted line is not part of the solution. It just shows the boundary.